Next thing that we can do is to improve our logging just a little bit more. So what often happens in microservices environment, and let me pop up my whiteboard here, is that you have a certain HTTP request that's coming, let's say, from certain Firefox application that Firefox browser and from the application that you wrote, and it ends up at certain microservice one, and it leaves some logs. And during that request handler, microservice one forwards it to microservice two, and so on to microservice three. Now, later on, if there is some problem, you need to understand and correlate logs from all of those three services with regards to the request in question. It can be a non-trivial thing to do when you have multiple, I mean, thousands requests being handled at the same time. All of the logs kind of intervened one between the other. So it's useful to have some common marker that goes from request to request. So we can introduce some random request ID string here, which will be picked up by M1 through headers. And whenever it calls to microservice 2, it will pass it on, etc., etc. And all the log messages that related to that particular request handling will have those RED strings attached to them. This way, for example, if you use things like track.js in our JavaScript application, we can pop up the problematic request ID from a track.js signature and run it through our logging system and see all the logs that relates to that particular request and its handling. Of course, you can use more sophisticated things like open tracing, yeah, but in simple scenarios, it's much easier to deploy something that I'm going to show right now how it can be done just in several lines of Python code. Particularly if you already have log collection system in place, that's really a simple thing to do. So let's see how it can be done with the help of the tools we use. Okay, so the feature we are going to use is part of the Uber logging. Uber logging has contextual logging support. It's kind of if you used log for C++ back in the days. It has that thing called native context logging or something like that, where you can, pair each logger, add some context tag to it, and all others who use that logger will will have that tag attached to it as well. Now we want to do something similar. I'll show you an example here. So what we basically do, we employ in the context vars. Context var is a new feature of Python 3.7, which is kind of unifies thread local storage paradigm that works both for threads and asynchronous and async tasks, right? So each time we create a task, new context is created, and whatever environment, whatever context and variables you set within that context, they stay in that context. So what Uberlogin actually does, it has a special request handler that, special formatter that you can ask Uberlogin to watch particular context variables and add their values as part of the log messages it produces. Okay, so again, a short example here. We create task upon our web server for handling a particular request, and every time we start handling a request, we set our particular request ID. This is our marker that we've talked about, and then all the log messages will have request ID attached to it. even though they run in parallel, and the log message itself doesn't have any reference to request ID as well. So let's see it in practice. The first thing, we need to go to bindings and create and register. Bindings and register our context variable, right? So we can do things like this. This is our context variable, and now I will initialize it straight away. I call it RID, and I just give it a name. Yeah, there is quite a good manual in the Python standard documentation on context vars. If I struggle to follow what I'm showing now, I advise you to have a look at it. So now I have a context variable, which is initialized, and I initialized like straight away on a module level. Okay, now we can tell Uber login to start watching this variable for every and install a special formatter that will actually check for every log record whether this variable exists and set there, and if it does, add it to a formatted log message. Okay, so we just pass it as a tuple here. Okay, so context vars are bindings RID, and that's the only one we have right now. Excellent. So we can run it now and nothing will happen. Right, I can start serving some requests here. For example, call get. And nothing will happen in particular because no one says that marker. So we obviously need to send it to set it in our application by ourselves. So let's do that. Let's edit our candles handler. And we already have our bindings, and let's start with the list. Okay, we can now say, okay, let's use secrets to populate that. Right, and we can say bindings, our context var, let's set it a value, and value will be just a random number. Let's say 48 bits should do. Okay, now to make it more interesting, let's again introduce logging here. We'll import our faithful struct log and take our logger at the module level, as we always do. And now we can say that we are listing candles here. To make it a bit more interesting, let's also add a couple of log messages to CandleDB itself. Okay. Okay, nice. Now, now it should already start doing something. Let's run it. Excellent. Now let's try listing the candles. First of all, it still works, which is fine. Now let's see if it does the trick, and it did. Now you can see we're saying listing the candles, and here we have our context added. Now you can also see for even loggers that have no relation to our application, for example, those that come from Unicorn, they also get tagged with that RID thing. Okay, so basically it means whatever is now part of this task, meaning the task itself, the currency task itself and all its sub-countings. Whenever they call the logger, the formatter looks up at the current value of RAD context var and just add it to the context. It also in JSON and goes to a separate entry. Here you see context vars. And if I fire a request here, you can see that it should get there. That looks like I hit some exception here. Yeah, here is our context var. Yeah, context var RID. Here it is. Right, so we have a context which is null. We don't use it like any contextual login, I mean struct log-wise, but we do have context var here and they're added. So now we can say, okay, fine, our small prototype worked. Now let's populate it across the rest of the thing, across the rest of the request handlers. So we can start doing things like here, like this, and like this, but it doesn't scale code-wise. It doesn't scale, and it's the same thing over and over and over. So since we're repeating the same thing, it was automating it. And there is a very neat way to do this fast API. Right, so let's create a new file, Hanukkah API utils. Right, and all this code is gonna do is to actually set a request, set the already thing, and I'll show how do we apply to all of our request handlers. So again, let's copy our secrets. We don't need them anymore here. We'll import our bindings. And we define our RID setter. For set log context, it doesn't need anything. It just says basically the very same thing it did before. Right, so it should be it. We have some magic numbers here, so let's put them to settings. In the server, we can introduce new properties. Let's call it RID bits. Integer 48 will be the good default. And here we can just now call the settings. Bindings, settings, come on, settings, server, RID bits. Not to forget to save it all. Okay. Okay, and here I don't need it anymore. So now we have something that sets the context var, but we need to call it in the right place. Right? Let's see how we do that. So we can say we want this globally on our API level. So we get to our API init file, and we just want to say that we want to do something as part of the before we start processing any particular request. Okay, and there is a neat way to do that. It's called dependency manager in Fast API. So we import a special helper class that will signal Fast API that this is something we want to be resolved before it kicks off the actual request handler, and then we register it. Okay, dependencies, yeah, so we just pass it a tuple, and we here from utils we import setlog context helper, and now we just can register it. Right, and it should do. So what we see here is we're saying, dear Fast API, Uh, Whatever you work on as part of handling requests for this particular router under /v1, please make sure to resolve this dependency first. And what this function basically, what it actually means is just make sure to call this function before you start handling the API, handling the request itself. Again, there is an excellent documentation within a Fast API docs about dependency management, and it can provide the gory details on what's actually happening here. So yes, so assuming that works, we can now populate the rest of our request handlers with useful log messages. Let's do that. Lighting a candle ID. Right. Okay, and let's populate add some more log messages to the DB itself. Checking for candle distance. And what else? Right, and for add method as well. Okay, that's good enough. Let's try to run it. Okay, we have a typo here, new utils. Come on, no utils, come on. Okay, bindings. Okay, Hanukkah. Let it be Hanukkah, perfect. So let's run several requests from here. List stuff. Light the candle. Let's say the first one. Off we go. And finally, let's create the fourth candle. Over here, and run execute. So now we can see how it works, right? So you see that every portion of logs that belongs to a particular request ended up with having a separate request context, separate request ID, right? So this is our first request ID, this is our second request ID, and this is our last request that went through. So now we can add propagation of this request ID whenever we are calling external services by themselves, which is fine. But first, let's see how we can take those headers, the thing I showed you in the whiteboard, how we can actually take the value of the request ID from headers. And this is quite trivial, but I'm showing this to introduce another powerful resolving feature of Fast API. So since Fast API uses Starlet, we're actually gonna use its request object to access the headers. So we import Starlet request, and now we'll use it here as our input, and we'll define our ID as follows. We'll say it's a string, take it from headers, and let's put it into settings, give it a name, X request ID. Okay, settings, server, RID header. Right, so, and let's say if it doesn't exist, then create a new one. Okay, Nice. And now just set it. So that's all that's need to be done. And let's see if it works. Hanukkah. I can now take the char value we had before. Let's put it on background, should we? And add our request ID thing, add our header manually. Instead of using random string, we just have a request ID as foo. Let's see if it worked. I didn't save again, as I usually do. That's fine. Run Hanukkah again on background. Oh, sorry. Okay, restarting our Hanukkah. Put it on the background so we can reuse the same console. And now let's fire our request. Okay, and now you can see that the Hanukkah logs here picked up our request ID from the header. Now, sounds like a bit like a magic here, right? And this is the reason I'm actually showing it to you. What happens is that because we declared this function as a dependency here in our API definition, what happens is REST API resolves dependencies in a recursive manner. So before calling setLock context, it actually looks on its signature and sees if there are any parameters here that he knows about and tries to resolve them all. So it recognizes it needs a request and it actually supplies the current request that's in the progress for our dependency function setLock context. And this is how this function gets populated. So I can, add other things. I can register other dependencies somewhere in the system and I can request them here and they will be injected as well. Okay, so this concludes the section about context logging. Again, for simple setups, when you have already login system in place, and if most of your microservices, all of your microservices, written in the same language, and you can really, in case of Python, just bring Uber login and really, literally in 5-10 lines of code, have your sort of basic tracing infrastructure in place, which can be a big win.